Hello friends, how are you? I hope you are well. In this video, I am going to describe about the different technical terms related to a lens. Very important. Technical terms related to a lens. So here I shall explain about the equiconvex or equiconcave lens, what is in our syllabus. Okay, now let us see. So this is C1, this is C2. See, I'm writing this is P, or here is the P. Okay, or you can consider this is P1, P2, or P1 is a point here, P2 is a point on this circle. So I have mentioned here technical terms associated or related to a lens. First point I am going to explain about the center of curvature. See here, there are two spheres are there. This is one surface and this is another surface. That means this left side surface is a part of this sphere and right side surface this is the part of this sphere. So here center of curvature in the sense center of the sphere of which the lens is a part. So I can say center of the sphere of which the lens is cut, or center of the sphere from which the lens is the surface of the lens is a part. You see that C1, it is the part of this sphere. C2 is the part of another sphere. This is the center of a sphere. In case of the concave, also same things I have written here. This is the first one I have written C1, second one I have written here C2. But here the lens is, I have mentioned here equiconcave lens. This is the lens. This one is the C1, this one is the C2. Here is the C1, here is also C1. This is about the center of curvature. Now we will see about the radius of curvature. Radius of curvature. So the distance from center of curvature to any point on the curved surface, that is the radius of curvature. So I can say this is the radius of curvature. This is the radius of curvature. I can say this is the radius of curvature. Distance from the center of the sphere to any point on this curved surface. Okay, so that is the radius of a curvature. You can say this is the radius of curvature. This is the radius of curvature. This is the radius of curvature. This is also a radius of curvature. I can say that this is also radius of curvature. This is also radius of curvature. This is also radius of a curvature. In the mirror topics, you have studied the distance from pole of the mirror to center of curvature is called radius of curvature. Here, if the lens is very thin, then you can say the distance from optic center to the center of curvature is also radius of a curvature. So this is about the radius of curvature. Next point is the principal axis. See the principal axis. Principal axis. So which one is the principal axis? The line joins. The line join C1 and C2, that is called the principal axis. Now, I said center of curvature, radius of curvature, principal axis. Now we will move one of the important terms, that is about the principal foci. Principal foci means focal point. Now you see, suppose this is a biconvex lens or equiconvex lens I have taken. This is equiconcave lens I have taken. So in this case, see here, first before saying the foci, it is better I shall tell about the optic center. Listen carefully about the optic center. Suppose light ray comes like this. Okay. Now this ray, it bent. Okay, bent. But you will find that this incident ray and the emergent ray, it seems parallel. Light is bending, it seems parallel. This is the incident ray. This is emergent ray. So here the incident ray, emergent ray looks parallel, but if the lens is very thin, whether it is the convex lens or concave lens, means biconvex or biconcave, if the lens is very thin, then this parallel shift we can neglect. If I neglect the parallel shift, that means the light ray, how it comes, it refracts like that without deviating. I said that this is thinner medium, this is thicker medium, no doubt, it is bending, but the emergent ray is parallel to the incident ray, and here the lateral shift is very less. Due to that, if it is a very thin lens, then the lateral shift can be neglected. If the lateral shift can be neglected, that means we can say that the light ray which incident a point on the principal axis, and after incident is refracting without deviating, that point is the optic center. So I can say that it is a point on the principal axis. Optic center, it is a point the principal axis at which light ray after incident refract without deviating, whether it is a concave lens or convex lens. If it is a very thin lens, I am representing this one is the convex lens, and this one I can represent concave lens. So it is a point through which light rays after incident refract without deviating, whether it is the concave or convex. So that central point is the optic center, or you can simply say that it is the midpoint of the lens. This is the plane of the lens, this is the principal axis, this is the midpoint of the lens. I can say this is the midpoint of the lens is called the optic center. Let us come to the principal focus. Okay? See. This is a convex lens. Okay? This is the principal axis. Now, from this point, light ray incident like this. After that, it moves parallel. See that? This is parallel. So, this point is called the principal focus. This point is called the principal focus. I have written it as F1. So this is the I can say this is the first focal point. In case of a lens, light ray can travel from either sides, either from left to right or right to left. That's why we'll get two focal point, one in left side, one in right side. So which one is the first focal point? First focal point is a point on the principal axis from which light rays coming, it refract parallel to the principal axis. From here light rays coming, it incident here, thereafter it refract parallel to the principal axis. This is about the first focal point in case of a convex lens, means a biconvex lens or equiconvex lens. If it is biconcave lens, you can see it, then it is different. In case of the biconcave lens, F1 will come this side. How? You see that? These are the light rays. Okay? The light rays comes, it deviate. It seems that it is coming from this point. That's why here is the F1. So in case of the equiconvex lens, the first focal point I found here F1, and in case of the equiconvex lens, concave lens, first focal point is at f1. So it seems that from this point light rays are diverged. This is about the first focal point. What about the second focal point? Just opposite. What opposite? You see that. This is the convex lens. So light rays are coming here. Those are coming parallel. They are meeting at a point. They are converging at this point. So here is the F2. This is F1. This is F2. So in case of the biconvex lens, we'll get principal foci, two focal point. Left side F1, right side F2. And so far as the biconcave lens is concerned, for example, the lens is like this. Now the light is coming from this side. Okay. So this is F2. The first focal point in biconcave lens, second focal point in the biconcave lens. Here is the first focal point in the biconvex lens and second focal point in the biconvex lens. Okay, and this middle point already I said, if it is the thing, then this point is the optic center. This is the optic center. Okay, so the distance from optic center to the principal focus is called the focal length. See here. Here I am explaining about the focal length. Focal length. Okay, that means the distance from focal point to the optic center is the focal length. Here is the focal length. Here is the focal length. Here to here is the focal length. Here to here is the focal length. Okay. So whenever we say focus, we understood here F2. Generally, whenever we say about the focus, that means we consider generally light rays coming from the left. Whenever we use in this syllabus, we prefer to say that this is the focus. But in fact, in both sides see, we will get the focus. Light can travel either from left to right or from right to left. Next point, focal plane. What is this focal plane? See, focal plane. Focal plane in the sense, the plane normal to the principal axis passes to the focus. The plane normal to the principal axis and passes through focus. Listen carefully. The plane normal to the principal axis. Suppose this is the plane normal to the principal axis and passes to this focus. That is called the focal plane. That is called the focal plane. Now you see that suppose this is a convex lens. Okay, the convex lens means biconvex lens, double convex lens. Now this is the principal axis, this is the optic center. Suppose here some light rays are coming. They are coming oblique to the principal axis. Oblique to the principal axis. Or they are coming parallel no doubt at all. Where they will meet? They will meet a point which is on the focal plane. Those comes parallel to the principal axis, they will meet at the focus. This is the focus. I said this is F2. This is the focal plane. Those light rays comes parallel but obliquely to the principal axis. They will meet at the focal plane. It is a point on the focal plane. This is the case of a biconvex lens. In case of the biconcave lens also similar things happen. What happens? See here. Suppose this is through the optic center. Like that number of rays are coming. Okay? So, they will diverge. But if it seems that they diverge in such a manner it seems that they are meeting at this point. That means this is the focal plane. This is the focal plane. How I said that? Those light rays are coming parallel rays, but are oblique to the principal axis. They will meet at a point on the focal plane. Whether it is a convex lens or concave lens, but they will meet at the focal plane. So in case of the convex lens, I said left side is F1, right side F2. But here right side F1, left side F2. This point is actually F2. So these refracted ray, they will meet at a point on the focal plane, the plane which is normal to the principal axis and passes to the focus. That is called the focal plane. Now, one more point I would like to say you how the refraction takes place through concave, biconcave and biconvex. Okay. So, just I shall tell you, later we will discuss more about this in the next video. Just you see that. So, I can say that refraction through a equiconvex or equiconcave lens. This is the biconvex lens or equiconvex lens. See here. Suppose one light ray is coming like this. Okay. Now I can draw normal at this point. So this is the, suppose you think this is the air. This is a glass. Clear? Now it will bend, means it refract at this point. Now this is the incident, now this is the refracted ray. For this surface you can consider this is incident. Then I can take one more normal here. This is N1, this is N2. Again what happened? It bends. Again it starts bending. That means the total refraction, I can take sum of the refraction, the total refraction here, the resultant refraction is sum of refraction at two surfaces, because both the refraction in one direction. Once it is refracting at this point, second time it is refracting at this point. That's why I can tell the resultant refraction, the total refraction is sum of refraction at two surfaces. This is the case of a equiconvex lens. Similarly, we can draw equiconcave lens also. Okay. Okay. This is the normal. Think that this is the normal N1. Okay. So it bent like this. Again we can draw one more normal. Again it bent like this. Okay. So here also it bent twice. Once at this surface, once at this surface, and both times it is traveling in one direction. So the resultant refraction is sum of the refraction at two different refracting surfaces. So this is about some of the technical terms I discussed about the center of curvature, radius of curvature, principal axis, principal focus or first focal point, second focal point, both in equiconvex and equiconcave lens. So this is about this video. In my next video, I shall explain the working of this type of lenses. Until then, bye.